we go. Today we are doing some test review, focusing on graphing a little bit more, but we're going to review here in Bellwork as well. Find the exact value of this thing. So when you look at this thing, I hope the first thing you notice is that we've got trig functions squared. And if you see trig functions squared, where should your eyes, or what should you think about? Pythagorean identity. So that's what I hope you think about. Unfortunately, that's not going to be the answer here, but let's look at it anyways. X squared plus y squared is r squared. I've got cosecant right here. Cosecant is r over y. So what should I divide everything here by? Divide everything here by y squared. If I divide everything by y squared, I get cotangent squared plus 1 equals cosecant squared. Well, that's great, but that is not what I have. I have cosecant, I have secant. I don't have cotangent. So that doesn't really help me. It is not a Pythagorean identity. What other thing would tell you that, hey, this is not a Pythagorean identity? Yeah, my angles are significantly different. This only works when the angles are the same. These angles are not anywhere close. One's a pi over 6, the other one's pi over 4. So this is not a Pythagorean identity. It's actually just easier than that. It's just do the problem. Okay, cosecant squared of 5 pi over 6. We are just going to do 5 pi over 6. So you got to think about where 5 pi over 6 lives on the unit circle. Okay, 5 pi over 6, that's in the third quadrant. Which one of those three lines is 5 pi over 6, top, middle, or bottom? Bottom, that guy right there. So you do the hand trick, boom. It is this ordered pair, radical 3 over 2 and 1/2. The x is negative because I'm in the second quadrant. If I'm doing cosecant here, Sam, which thing do I want if I'm doing cosecant, x or y? Y. And what do I need to do with that thing if it's cosecant? Flip it. So it's 2, and I'm squaring it. That's what cosecant squared of 5 pi over 6 is. It's 2 squared. Okay, then we're going to do the same thing with the second one, so we're going to add to that. Secant squared of pi over 4. So again, we're just thinking unit circle. We're pi over 4, so we're right here. Which one of those is pi over 4, top, middle, or bottom? Middle. Doing the hand trick, it gets me radical 2 over 2, radical 2 over 2. I'm doing secant, so if I'm doing secant here, Eli, which one of those things do I care about, x or y? X, and what do I got to do with it? Flip it. And so it is 2 over square root of 2, and I'm squaring it. You might want to rationalize it, but you don't have to because I'm squaring it. Okay, then I just do that math. So 2 squared is 4. 2 squared is 4. Radical 2 squared is 2. And so my problem then becomes simply 4 plus 2, which is 6. Questions on how I did the first one? Let's do the second one. We're graphing tangent 2x minus pi over 4. Start off just like we do all of them. Let's start off with amplitude, period length, vertical shift, horizontal shift. Let's throw some domain and range at the end to make sure we got it. All right, let's see what we got. Amplitude. If we're doing amplitude here, Kate, what's my amplitude going to be? 1. What about base period length here? It'd be pi, but then I got to do what with that? Good. We're going to multiply by the reciprocal, so we're going to multiply by 1 over 2, so it is pi over 2. That is my period length. Good. Once I've done that, then I'm going to do vertical shift. I don't have one. What about horizontal shift here? Herman, what am I going to start with for horizontal shift? Yeah, it is a phase shift. You're absolutely correct. To me, the words are interchangeable. Phase shift, horizontal shift, they mean the same thing. So don't be confused by that. So what is your base shifting that you're going to do here? Pi over 4. And then you need to, because it is a phase shift, because there's something in front of my x, because of this right here, what else do I need to do with that pi over 4? Multiplied by the reciprocal, just like we do period length. And so I am going pi over 8. And by point, which direction am I going pi over 8? We going to the right. Is pi over 8 to the right because it's minus. Cool. Let's put it on my graph. 4 hash marks. 1, 2, 3, 4. The fourth hash mark is pi over 2. That makes this guy pi over 4. That makes this guy pi over 8. This guy's 3 pi over 8. Amplitude is 1, and I don't have any vertical shifts, so I'm pretty much ready to go here. It is a tangent graph. What would normally happen here at the y-axis of a tangent graph? Would I have an asymptote line or would I have the vertex? vertex, but it's not going to go there. We just said that we got to shift to the right, pi over 8. So how many hash marks do I need to move? 1 hash mark, pi over 8. Boom, there's my new midpoint. That's my new vertex. That's the middle of this graph. How many hash marks to the right do I need to move to make an asymptote line? 2. Because remember, we made 4. We made 4 at the beginning. By making 4 at the beginning, that was our period length. That's telling you that's how long it's going to span. So if I'm in the middle, then I need to go 2 each direction. That would tell me the 2 asymptote lines. Okay, that's one way of thinking of it. I don't know if that's the best way, but that's one way. Boom, there's an asymptote line. It is a half a pi away. I know you're not good with fractions, but pi over 8 to 3 pi over 8, that's half a pi, which is what, I'm sorry, a quarter of a pi. I can't even say that right. That's a quarter of a pi away, which is what I want, because I'm a half a pi from one asymptote to the other. So I need to go a quarter of a pi one way. I need to do the same thing the other opposite way. So if I label this over here, it'd be negative pi over 8. It is a tangent graph, so where am I going to start? Am I going to start at the bottom and go up, or start at the up and go down? Bottom and go up. So I'm starting down here. Whoa, that's way too skinny. Start here at the bottom, work my way up, and then do your best not to draw an ugly tangent graph. Connect. Too late. Connect those dots. There's my graph. Domain. All real numbers, but x can't be. Aaron H., what's something that x cannot be with my domain? It cannot be 3 pi over 8, because right there I have an asymptote line. And then I'm going to add to that the repeating pattern. How often am I going to have an asymptote? Pi over 2, because on a tangent and a cotangent graph, that's how often I'm going to have one. So plus pi over 2. N. Yeah. N pi over 2. Or pi, yeah, that's ugly. N pi over 2. Because it's going to keep repeating and repeating and repeating. Range, all real numbers. Questions there? Go ahead and put your bell works together. Today, we are focusing on graphing. Okay, you've done it on your own. I've seen you do it, but I want you to be able to do some whiteboards today, because you showing me what you're doing is going to allow me to fix some mistakes that we might have. Okay, so if you have a dry erase marker, the graphs I'm going to give you today are difficult. Okay, I'm giving you tough ones. On a scale of 0 to 10, I'm trying to give you graphs in the 7 to 9 range. Okay, if you can handle those, then when I give you a test and I'm giving you ones on the 5 to 7 range, or the 5 to 6 range even, they'll seem a little bit easier. So don't be discouraged if at first glance you're not perfect at these. Okay, let's start off here. Let's go with negative 2 cosecant x plus pi over, x plus pi over 2. We'll throw a minus 1 at the end. Graph that, amplitude, period length, all that good stuff, and then tell me domain and range at the end as well, please. See what you can do. Go. So first thing we're doing, I'm going to go quick through that because you guys did fine with it. Amplitude is 2, and we flipped because it was negative. Our period length is 2 pi. My vertical shift is down 1, and my horizontal shift is pi over 2, and we're going to the left. Okay, so this is my midline. My amplitude is 2, so I'm going up to here and down to there. I'm graphing cosecant. So what am I actually graphing if I'm graphing cosecant? Sine. Where does a sine graph start? Top, middle, or bottom? Middle. Okay. Middle. I forgot to label this. Give me 2 seconds. 2 pi, pi over 2. So we start in the middle. I'm going to the left pi over 2. That means I'm going 1 hash mark to the left of pi over 2, and I'm still going to start in the middle. It is a sine curve, and I've been flipped. So once I'm in the middle, then I'm going down, middle, top, middle. Okay, we can make this graph here. Once I've made that graph, that's not what I'm looking for. I'm doing cosecant. So if I'm graphing cosecant, then I'm going to go ahead and put my asymptote lines everywhere that I have a cross the 0. So right there, right there, right there. So I have a parabola starting here and going down, and I have a parabola starting there and going up. For the most part, we did a pretty nice job with that. Let's talk about domain. Domain. X is equal, I'm sorry, all real numbers. But X cannot be. X cannot be anywhere I have a vertical asymptote. So as I look at this here, Aaron, see, where's my first place, or where is a place that I have a vertical asymptote? So, okay, so we're going to start with pi over 2. And then we're going to add that, however long it takes for me to get another asymptote. So think about that. This one's at pi over 2, and my next one is at 3 pi over 2. So the difference between that is pi. So it'd be that plus n pi. A lot of students are going to say, hey, my period length is 2 pi, and so I'm going to add 2 pi. That's only true with tangent and cotangent, okay? Because tangent and cotangent, you just have it your period length. But here, think, I've graphed one period length, and I have an asymptote line right down the middle of it, okay? And so I'm going to have an asymptote line every pi there, so it's a little bit different. If I'm doing range here, okay, that's where does my parabola actually touch, okay? So think about that. Ella, when I'm graphing that, we got this segment and above that red line. So basically, we don't want in between the two red lines. So what would you say your domain is going to be, or your range, sorry? Wonderful. 1 to infinity. Yeah, good. 1 to infinity, good. Because we've got that no man's land. Basically, I want everything but this spot in the middle in between these two asymptote lines. That's the only place I don't care about. Questions on the first one? We did pretty well with that. Cosecant takes a while to graph. We did a nice job. Let's do it again. All right, I'm just going to write the equation, then I'll delete everything afterwards. All right, here's what I want you to graph. Let's go with y. No, my program crashed. Good times. There we go. Let's go with y equals 2 sine. No, we just did sine. Let's do negative 2 cosine negative 4x plus pi over 2. Yeah, we'll leave it there. I like making them tough. They're tough, great. You'll be good at them if you can do the tough ones. Go. We are graphing this guy. A lot of stuff going on here. Let's see what we can do. Amplitude is 2. Period length is 2 pi, but then I got to multiply by the reciprocal, so it's 1/4. So my period length is pi over 2. My vertical shift is nah. My horizontal shift, I start off with pi over 2, and then I'm going to multiply by the reciprocal of whatever's in front of my x. So I'm going to multiply by 1/4. I get pi over 8. Now, the biggest mistake that we made anywhere was which direction am I going pi over 8? It's plus sign here. So normally I think, oh, it's a plus sign. I would go to the left. But I've got that negative in front as well. Okay, and remember, we could factor that negative out and get me the minus sign there, which is going to take me or tell me to go to the right there. So that is a right shift pi over 8. Okay, so when I graph this thing, make my 4 hash marks, 1, 2, 3, 4. This one is pi over 2, pi over 4, pi over 8, 3 pi over 8. My amplitude is simply 2, so I'm up 2 and down 2. It's a cosine graph, so normally I would start at the top, but it's negative. This negative, does that flip me? No, because it's inside the parentheses, and with cosine that doesn't matter. But this one does, and so I am flipped one time. Okay, so it's a cosine graph. It's going to start at the bottom, so normally I would start here, but I'm going to the right pi over 8, so my new dot is going to start right there. Once I've got that one, a middle, top, middle, bottom, and you could continue from there and get your picture to do something like that. Domain, it's a sine or cosine graph, so it's always all real numbers because there's no asymptotes. My range, my graph lives in between -2 and 2, so that's an easy one as well. Questions on that one? Yes, ma'am. Yeah, so tangent or a sine graph or a cosecant or a cotangent. Remember, with cosine and secant, that negative inside the parentheses does not flip it because the idea is that it's an even graph. That's a horizontal flip, and that's the even odd identities. It has y-axis or Yeah, y-axis symmetry, so it's not going to change it. It's weird, but that's the concept that's going on there. Let's do one more. Let's do this. Let's go y equals, let's go negative cotangent negative 1/2 x plus pi minus 1. Let's graph it, see what you can do.